in the previous 4 to 4 minutes that you have tried to make the Excel sheet, which is very important for all of you. I have uploaded the three first lectures, but one lecture is remaining. So I will upload by tomorrow on the Saturday, and I will share the link in the group for the both these lectures. So try to practice these things as yourself. If you have any type of question or any query, you can raise the concern in the group. When I will available in the and I will try to also as per my knowledge. So today is very important lecture. So we will uh, move to the our lecture. I'm just sharing my screen. First of all, we will see what are the basically bondings and other things. Then we move on to the so can you see the screen right now?
Yes, sir.
Okay, thank you. Basically, this is the MV cable data sheet from the vendor. Okay, vendor data sheets. They have just provided me the vendor data sheets. So you should see that they have just basically mentioned the area of the cable. Area means the cross section of the cable, one 630, 400, 500, like this type of. Then the conductor outer dia. So you should see that this is the conductor overall dia. Like when I will mark these things, like highlight when I will upload the thing here. So basically, this is the conductor outer dia. So this is the conductor outer dia. They gave us that should be the conductor outer dia should be 31.5. Number of cores should be single. If we have three core, you have different things. If you are not aware of that, I will show you three core cable. Here, here is the three core cables. So you can see that these have the three core cables. Our four core cable here is a one black cable core should be mentioned there. So that is the blue, red, red, yellow, blue. That is the philosophy. But this cable is single core cables. They have already mentioned that it should be the single core. So the type should be the standard circular compact aluminum, and then they have the conductor screen. So they have mentioned these things, like they have mentioned that PVC sheet, they are giving indication to that one. They have mentioned that PVC sheet is the black above the top one sheath is called PVC sheet. And then aluminium wire armor. This is the aluminium wire armor, this white one, the circular, for which they have indicating. Then they also have another black sheet type material. They have PVC bedding. They have PVC bedding. And then they have another white and yellow type available in that one. They are basically 36 by 1.1 copper wires. This is basically the sheath. Sheath are metallic screen. Metallic sheath are metallic screen. We have basically this is. And which in the yesterday lecture, I have just mentioned that the bonding of the cable means that this metallic sheath, basically this is the copper wire. So this is the metallic sheath and metallic screen we should use as a metallic sheath or metallic screen. So we have to uh, earth these metallic screen. If our cable length should be less than uh, like 1500 meter, I think 1500. I don't remember actual length of the cables, but at certain length, we use only single bonding. Single bonding, this is only, these are the bonding types. Single point bonding, double point bonding, and cross bonding. So here, basically, one end of the cables, like we are terminating the cables at one in the MV switchgear, and other point is to the IPP MV switchgear. So in one end, at like on the substation or on the PV area, we should have to earth the metallic screen. We have to earth that one. But the other one, we have to insulate that one and not to earth the end. This is called the single point bonding. No circulating current, heavy sheath voltage at far end. At far end, SVL requires. SVL mean that uh, basically uh, these are required to minimize the current. These are the like devices type, but they are not recommendable at that moment. Short cable and long cables, no usage. Then the double point bonding, basically they both end should be earthed. They both and should be earthed. But they have some issue because the circulating current is higher, and its voltage is lower. So when the current is in the higher in the sheath, circulating current, the sheath will be heating up, and they generate the heat in the sheath, and the cable should be the temperature should be rising. uh, the reason I have mentioned that in the yesterday lecture, that we have faced that a lot of issue on the side, our cable sheathing will be burned. So that is the reason why the cable should be burned when we have basically proposed the double end point bonding. So that is why the circulating should be in the higher low sheath voltage and higher losses, and that is why the sheath will be heat up and burn. Then the third one is the cross bonding. Cross bonding means that it is basically used for the long cables. For the short cable, we only use the single point bonding. For the long, we have to use the cross or double bonding. Uh, Double bonding, basically they generating the heat, and also uh, maybe the cable temperature will rise above the maximum limit, like the 90 degree temperature of the cable, and they will burn the sheath. So the cross bonding is the best way solution at the joint point, like we have 400 meter cable one, and the other is the 3 meter cables. So we have to use the cross bonds. Basically, cross bonds means that they have the single three course cable. They are in the travel uh, forms. They are traveling and lay in the crunch. But at joint point, we have to like give them the three. If our cable is too much long, and we have to give them the proper three areas, like 3 points. We have to use the two joints in between that, and each joint we should like, we have yellow, red, yellow, blue, and the other like that one. So we will just do that. Red should be connected to the other blue, and either blue is to yellow, and this type of the cross bonding, we use that one. Like in the three, they will shuffle to each other. So in that case, the cross bonds sheet, no circulating current, high ampacity, and complex design, long cables, and no current. So that is why no sheathing burn issue will generate. So this is complex, and they have like expensive one. So most of the contractor will try to avoid that or not to use them. But as per, if you will follow the standards, proper IC standards, and other local standards, then we have to use the cross bondings. Like this is the semiconductive wire material, and then we have this semiconductive insulation screen. So we have this black one. Yes, Amar.
सॉरी टू डिस्टर्ब यू सर। सर मेरा क्वेश्चन था कि केबल्स में अगर देखिए हम जैसे सिंगल उसके लिए जब या पिक्चर जो केबल की भी आपने ओपन की थी वो काइंडली ओपन कर दें। दूसरी सर पिक्चर।
यस।
सर जैसे सिंगल पॉइंट बॉन्डिंग के लिए हम एसपीएल यूज कर रहे हैं तो हमें डबल पॉइंट के लिए भी तो यूज करनी पड़ेगी ना, ओवर हीटिंग तो यहाँ भी होगी सर,
इस
क्योंकि
वजह
सिंगल
से
जैसे शीट देखें शीट वोल्टेज लिमिटर हम यूज कर रहे हैं ना सिंगल पॉइंट बॉन्डिंग के लिए। तो
हम्म
उसमें तो ओवर वोल्टेज वगैरह हीटिंग हीटिंग पर्पस के लिए तो हमारी डबल पॉइंट बॉन्डिंग और क्रॉस बॉन्डिंग में नहीं होगी।
no, basically in the cross bonding no circulating current. Basically they will cancel each other, because when they are the cross bonding, their induced voltage should be cancel each other. So when they cancel each other, no current should be flowing. So that is why we don't need to use the SVL at in that cross bondings. But in case of double, we have to use the SVL. But most of the things which we have faced a lot of issue on the side, and we have like lesson learned for that for our teams or other thing, that SVL basically sheath voltage limitator we use. Basically, they are like the complex one and expensive one. So that is why uh, most the contractor will not use that one. SPL for the single end bonding, most of the time they will not use, like not require that one. When the length is like as per the standard, it should be the length limitation is like 1500 meter, and our length is approximately near to that one, and we see that our sheet current are will be rising in that case, then we have to use the SVL. But when we have to use the SVL, we mostly avoid that one and convert to the cross bondings.
सर सो वी मोस्टली यूज क्रॉस बॉन्डिंग
Cross bonding is the recommended one for the long cables.
फॉर लॉन्ग केबल्स, बट
Yes.
इज दिस complex design, so this will be the
Yes,
complex
it
for us.
yes it is complex one, but it is safest one.
Okay sir, thank you.
Okay, thank you. So basically, this is the semiconductor insulation screen. Screen mean that should be this XLP insulation. They have like the protection for that screen. And then the third one is the, like this is the binders tapes and binder tapes. These things small one. And then we have another black one, semiconductive conductor screen. And then we have compacted cables. So this is the cables we have mostly used in our systems. How they will see and what are these things. Like you have seen that they have already given that insulation sheet, insulation detail, like conductive screen, XLP1 thickness, then insulation thickness, then the core screen, and then the core diameter, and then the metallic screen, like wire screen, and the tape, like other things they have. Then layup details like that one, PVC, other things they have given us. So when we are doing the thermal assessment of the cables, now I am converted to the my software. Basically, this is the CYMCAP software. It is like a paid one. But if you have needed this one, the like this software, we have one guy which I have contacted on the Facebook, and they will like give us the uh, like in the 75 USD. Previously, they are purchasing in the 25, then they have raised the price to the 75 USD. Now I don't know what are they offering these prices. They are basically giving you the uh, like the crack one, crack, but in purchase form. Like PV case, we are using the purchase original purchase software of the PV case is too much expensive one. But most of the companies are using the crack one they purchase from some hackers like this type. They are hackering like this type of the things. So this is the same case for the PV SIMCAP software. So in that software, we have different studies option available, and we have to make the cable, the duct bank, other things. Okay. So if we have to use like the study, like I will show you in my, this is the study, like I will add it in that one. I have just made this study. Okay. Here is the option available. Multiple duct bank, backfill, casing, and other things. Then we have duct bank, then we have backfill, then we have directly buried and duct back. Then we have cable in the air, the cable in the tunnels, the cable in the trough, J tubes, then the submarine cables, the 3D modeling, then cable in the casing. So here is the things available. I have applied this formula. The keep backfill. Backfill mean that we have to use some sand and then we have to backfill that cable one. This is like green. This is the surface level where we are undergrounding our cables. So, but the issue is that in this software, first of all, we have to make the cable automatically as per our uh, like vendor data. We have to make the cables. Then we use that cable. Okay. Uh, like here, you can see that I have made this cable. Made this cable. If I use see that cables, we have make them like they have. I have conductor aluminum standard, then the diameter, then insulation XLP, then the sheath lead, then I have the constructed wires aluminum, then the jacket of the PVC, the overall diameter of the cable, that one. I have used that one. And I have made this thermal assessment of the cables. Like if we select on that solver, if we apply that solver, you can see that they have mentioned that at 200 ampere, the temperature of the cable should be 78.1 degree centigrade, 77.2 degree. Like you can see that they are giving us the cable. Here, basically, for the single phase circuits, single phase, they have one issue in that software. They are not giving us the option of the neutral one, neutral cable. They only give us the phase cable. But in our case, we are using the double runs of the cables. In the DC cables, we are using that basically the double runs of the cable. That is why you have seen that they automatically divide the current like 200 ampere, 200 ampere for that one. They basically not automatically divide that one. I have just given them the load like divided one. Like I have 400 ampere the load current, and I have divided one by one. So this is the study like that. Now, if we will do some study, but I just showing you. This is the report option of that software. Like I will click on that summary of that study, cable input data, electrical, like short circuit result and other things. No, okay. If we see that one, you can see that the Excel, like here is the Excel sheet. You can see that I have just mentioned that the soil depth, the native soil, that the soil resistive of the backfill to then the core center backfill like this one. They have just given that data. Then they have made that section with a proper screenshot. Then they have mentioned the cable, the circuit one, circuit two, circuit in this one, that one. Then phase current, then the X and Y position, then the daily load one level, then the conductor no bonding available. bonding type. Because in the DC and AC, LVAC, we have no need of that bondings. But in case of MV, we have needed that bonding. Because in LV, we don't have metallic screen. We have only armor. But in case of MV, we have metallic screen. That is why we needed that bondings. Then they have mentioned the temperature of that one, sheath, armor, then the cable surface, then the duct surface. They have just mentioned these things available. Then we have see that they have the temperature like this type of thermal this is outer covering, banding, and other things you can see that. So this is the optimized cable. This is the coordinate, then the conductor temperature, then ampacity, then other things like that one. They have the calculation, DC resistance and other things. They have mentioned that one. Okay. So this is basically how we will calculate the basically this is the thermal assessment of the cables. And now we can see that our cable should be okay. Like uh, 240 cable is okay. They are satisfying the criteria. Okay. So we will first of all we just go into the back side. First of all, we have to make one cable. Okay. First of all, we have to make some one cable like data. So we just make this cable like MV cables. Yes, we will make a one MV cables like that one. You can see that they have just given us that data. So when you are making that cable, you have to need this type of data from the your cable vendors. So first of all, you have to do the cable which are basically already made in that directory. So you have to check and you have to click that one and then you have to edit that one. Because if you can add the new cables, but they in case of MV they have some limitation that one. Because the software which I have, it is basically the crack one, crack purchased one. So they have just standalone user. But if you have purchase original purchase one software, they have different uh, other options that one. So you can use that one. So that is why I'm just giving like one cable I am selecting like 33 kV. So like here, we just uh, this cable we have already made that, and then we will made uh, new. And do you want to use the current cable selected as a template? Yes. Then we just give them the name one like this type of the title should be like 303 something like this type of, and then we have to comment and that this one. Okay. Now you can see that we have made that cables. Now we have to change that cables. Okay. Now we have to change that cables. First of all, our cable size is 630. So first of all, you have to change that voltage or conductor sizes from that one. So we just select on the conductor size and change to the 630 mm. Okay. So here, here we should change the diameter. Like we have already that one, and when we click on that green blue options, we can add them option one. So we just click on that. We have just mentioned that it is aluminum conductor and extruded one, and then the diameter. So in our case, the diameter should be 31.5. So that is why we have to change that one to the 31.5. Okay. Then next, then next should be the XLP on conductor sheet. This shield should be XLP unfilled. So the diameter of that, this is in conductor shield sheet. So this is the core screen. This is conductor screen. This one. This is basically the sheet, and their thickness is XLP, but its thickness is 1 mm. So we should change to the 1 mm. Okay. Then we should need to the insulation. Now our insulation should be XLP, but 8 mm is the thickness. So we change it to the 8 mm. It is already 8 mm thickness, and this is the XLP unfilled criteria. Then we move on to the another insulation screen. So we have another core screen or insulation screen are the same one. We have this one XLP 0.6 thickness. So already we have 0.6 thickness semiconductive screen. This is basically uh, the semiconductive uh, strippable XLP screen. So we move on to the next one. Then we have the concentrated wire. This is basically, these are the things. We have this type of metallic screen, copper wire cables. We have copper wire. So number of wire are the 36, and the screen area per core is this one. So we have to give them the number of wires. We have number of wires, that one. The diameter, like this should be the same one. So uh, another thing, the thickness should be remain same one. So we move on to the next, and that should be the copper one. Okay. We now move on to the another point. This is basically armor bedding. Armor bedding is that one. This is this is the filler. This is bedding type. PVC 1.5 thickness. Okay. So it is already 1.4. So we make them 1.5. Then we move on to the next one. That should be the armor one. Armor one, it is already mentioned that armor AWA aluminium wire armored. If it is mentioned that SWA steel wire armored. So that is one AWY armor, and number of the armor cables should be 66, and the diameter of one 2.59. So we have these customized magnetic wires. Okay, because in that aluminum is not available, so that is why we make them as a this one. Thickness should be 2.59, already that one available, and then the wire should be 60. Number of wire should be 66. Okay, 66. So we move on to the next one. Then this is basically the jacket 2. Jacket 2, this is the uh, jacket 2 should be the PVC. Okay. Uh, yes, this one. Jacket 2, the thickness should be like 2.91, last one. So we make them 2.9. Okay. Then we move on to the next, that is okay. End up, then we okay. Then we have to save that one. Okay. They basically not giving the save because we have already made that one. So how we will make then the cables like this type of the, you have to just uh, check from the directory and change the cables as per your data. So we make a one study on the cable, like, so we are making a new study, mm, like, okay, yes, this is N type. Okay. So this is basically the study available. So we have to like change that one. If we make them clear that one, So if we click on that installation data, we have that cables data. We just delete that cables. This is the delete option available. Also, this is the delete option available. So if we want to change that, we just double click on that. If it is not available, uh, it is available already. So I think we need no need to that one. We just need study. No, we just made that one. And why title the assessment thermal assessment TAVT. Okay. So we are using the temperature temperature one. Okay. So we have to like select the option from that one. Duct bank, backfill, direct buried case. So we are using that backfill installation. Select that one. We have to define the ground temperature. Like we have 30-degree temperature. Like native soil mean that the original soil of that cable, that trench where we are basically laying the cable, and we backfill dig that area. That uh, soil thermal resistivity should be like we have two. Then the backfill we have like sand option. Like I have show you the one section in the previous lecture, and in that I have mentioned that this is the sand area. So we have to make that sand area. Like we have uh, 0.3, because they are in the meters. We have 300 which should be like 1 meter. Okay. And this is basically center of the backfill center. 0, 0, it is center. But we now make it 0.5. And then y should be like we have given that like 1 meter from that backfill. And that backfill, with that sand, basically we have 1.5 soil thermal resistivity value. Then we have to select that installation option. Three-phase circuit, one core cable with the spacing, three-phase circuit, traveling form. So we are making three-phase circuit with the 20 cable per month. Three core cables, that option we are using basically. We are using like three circuits there. Okay. Okay. Now we have to we have to select the cables first of all. So here we just click on that non options, and we have make that cables like available in the directory. Like we have MV cable. That is like MV cables. We have MV cables. I have make them. Okay, they are basically called the value X locations. So this is the installation option available. This is installation option available. So we are giving like we have 1.5 that one, and we have like this one like 1.1 meters available. Okay. Then we again make double click on that one, and then we have to select the cables. We have make the cable like 300 cables. Then installation point, like we have to give them the center to center distance. Like we will give them 0.15 to 300 cables, 0.45, and this is 1 meter Y options. Then the third one, we again select the cables. We make single core 400, and then we installation options. 0.75, then this should be 1, and we select that one. Now we have to give them option of installation data. Like we have ampacity. We have to select the ampacity. What are the ampacity on these cables? Here I have 120, 500. Here we have 250, and here we have 120. Sorry, 250 here, because we have 250 here, and here we have 125. Apply. We apply that one. Now when we are selecting that, they are basically saying the complete the specific installation data. So here we have to select that one. They are basically saying that it should be like the bonding options availability of that bonding. We have just sheath bonding and triangular configurations. They are not allowing us the cross bonding at that moment. Why they are basically doing that one? If we use the cables like this one, cables type. So this 630 we are basically using, and then I just selected that 409, 300, this one, and then we have again 400, like this one cable. Okay. Now basically we have to give them the installation data. This is the specific installation data. So sheet bondings availability, you have seen that they basically enable the sheath bondings and triangular configuration. This is the double, and this is single point bonding, and this is the cross point bonding. When we select the cross point bondings, we have to duct options that basically cables not in the duct options. Then we have to select that one. Cross bonding length uneven equal minor section length. Cross bonding cable length. Apply that one like this type of. We have to give them that length is. So basically, we see that it should be equal that one. Apply the frequency like we have 50-degree temperature frequency. Okay. Next cable, because they are the different cables, so that is why we have to check again that they are not in the duct material, and then equal length should be 50. Then the next cable, no cross bonding, because we have selected the DC cables, sheath bonded at one end, like we have selected that one, and then we have, selected not even. Apply the frequency like that one, and apply OK. Now we will check then the solve the options. What are the options that? Now you can see that they have already apply that at 500 its temperature should be higher. 125 temperature should be 100, and 250 should be 27. So that showing that our cable not satisfying the criteria. We are overheating that one. So that is basically the thermal assessment of the cables. How we will do that properly? Because we have just short one lecture on the thermal assessment. Because thermal assessment needs some detail calculations. So if you want to do that, you will try your things, and I will just give you the overview of that one in the one lectures. How we will do that? What is the basically purpose of that thermal assessment? Most of the things in the small scale project, no need of that thermal assessment. But in large scale project, we have to do that thermal assessment because the consultant will not accept your cable sizing without that thermal assessments. So that is it for the today. I think I will try my level best to convey the knowledge in that one lectures and basic knowledge of the thermal assessment. Now, if your time to ask the question, if you have, then I will explain and we will end up our today lectures.
सर
Yes.
सर अगर हमारा बेस्ट प्रोजेक्ट होगा लार्ज स्केल पे, तो उसके लिए हमें थर्मल असेसमेंट के लिए ये सॉफ्टवेयर होना ज़रूरी है, या हम एक एक जो है assumptions के लिहाज से दे सकते हैं एक?
Basically, Amar, it should be depend upon your client. It depend upon your consultant. Basically, when you are doing the best large scale project like 200 megawatt hours, 300 megawatt hour, 500 megawatt hour, the client will not check your drawings and not check your installation. Basically, they will hire some consultants. Like you have seen in the Pakistan level, most of the time you have seen that the government projects, most of the time the consultant will ask you the question, will accept your drawings and other things if you have done any government projects. Basically, government will uh, like uh, but you can say that hire the consultant, and they are it is their responsibility to check the drawings, to check proper calculations, to check everything, and then they will approve the drawings, approve the calculations, approve the overall design, and then installation will start. So if you are doing the large scale best projects, if the consultant is a technical one, that they must require that thermal assessment. Without any assumption, because in the large scale project, when you are doing the cable sizing, you have to done before that one the geotech investigation report, that they will give us the ground temperature, soil thermal resistivity value. On that basis you will properly size your cables, and then you have to import the sand which you have to use as a bedding and cover, like 100 mm, 200 mm, as per the client requirement, ER requirement, employer requirements. So then it is the company responsibility to purchase the software, to hire some other person which they have this software. So it is company responsibility, and employer must mention in the ER the requirements that you have to the purchase one software, and it is not a like mm, uh, employer responsibility to give the software. It is contractor requirement, contractor responsibility to purchase the software. So you must have to the software for that, like the thermal assessment. Then you have earthing calculation. So you have must software for that one. Okay.
Yes, sir.
How much size you are working on the best systems right
Sir,
now?
we right now we are working 2 megawatts, sir.
2 megawatt or 2 megawatt hour
2 megawatt system, best project.
as project?
Like,
How much
yes,
size of
like,
the high? How much size of the best? You have seen that best system will be sized in the megawatt hours, not in the megawatts. How many megawatt hours of that system?
yes, sir. 1 minute. Sir, uh, we have the load is 187 kilowatt, no?
Okay. How
Okay.
much time? How much time you have to run that load?
Okay. Solar time, sir, 9 to 5 p.m. 6 hours, sir.
No, 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 no.
On,
Basically,
hmm.
when you are doing the best sizing, you have to need you have to require the load list from the client, and you have to need that working or times are in which this load will be running. Like we
Yes,
have
sir.
if we doing the best sizes for the small systems, we need the client that how many equipment or how many appliances are in your house, and what are the time they will run in the day or in the night times. So you have to run that loads on the best. So you have to need that running hours and then their powers. Then you will calculate their uh, best systems.
Sir, we are currently launching the best projects of my company. So हमने जो अभी अभी जो किया है कि हम खुद जो है ना एक चाइनीज से कोई भी अगर हम पूछते हैं तो वही के उन्होंने हम प्रोडक्ट्स दिए बेस्ट प्रोडक्ट्स लाइक आपने बताया पीसीएस हमें दिया हुआ है और इन्वर्टर है उसमें उसके बाद है एसटीएस और बैटरी। तो जब हमें हम एक प्रपोजल तैयार करते हैं कि भाई क्लाइंट की क्या नीडेड्स है तो फिर हम चाइनीज से जो उनके प्रोडक्ट्स हैं उनके बारे में फिर हम उनसे पूछते हैं भाई आप हम ये सॉल्यूशन उनको दे सकते हैं लाइक अभी एक हम बिगिनर जो है स्टेज पे हैं सर।
Okay. Okay. So basically, I have seen that uh, when large scale best projects, we win that one. Like in our company, uh, we are working on the uh, three 300, I think, yeah, or 240 megawatt hour projects. Our company is working on that in the detail stage projects. So in that case, like primary teams, they are working on that project. We are not working on that project. They will basically they will develop a one layout in which basically they give us that requirement to the uh, different like Sungrow and other things, other companies. They are providing the best containers. So we have used that containers, and then we have connect these containers, and then we use the PCS, and then we use the transformers. So sizing like the same one which I have explained to you, but now these days they are basically the containerized solution. The different companies will give us that how much the megawatt hours in one containers. Then we have to use that container as for the solutions. Okay, okay, Mar. Which company you are working right now?
Sir, Inverex.
Sorry,
Sir, Inverex Solar Energy.
Inverex. Inverex.
Yes, yes, yes.
Okay, okay. Inverex. You know the one guy Hafiz, which I have worked in that company previous year, I think.
Sir, I don't know if he's.
Please. Now they have left that company, but previously they working in the company in the Inverex. But Inverex Solar is like the too much old company, and they are working on the small projects.
So now they initiate large scale projects, sir.
This year they are initiating the large scale project.
Yeah, yes.
That's great. Okay, guys, we meet on the Monday, inshallah.